Alright, so welcome back again. My name is Jesse, and in this wonderful tutorial we're trying to see how to work with a very nice package called TPOT. So what is TPOT? So TPOT is a powerful Python library that allows us to automatically generate ML pipeline, right? So in other words, it's going to help you find the best optimal ML algorithm as well as their parameters to do your ML tasks. So it uses genetic algorithm, which is a format of optimization in which you're trying to find the optimal solution by using natural selection or survival of the fittest, or maybe Darwinian concept. So it uses three main steps. There's the selection stage, the crossover, and then the mutation. So at the selection, it's going to find the best from among the rest, and the fittest among the rest, like natural selection. There's going to breed the best and the fittest to create a new generation. Then the final stage is going to mutate them to get the best and the strongest, right? So that is what it works. That is how it works. So it's using optimization by using genetic programming. So let's see how to work with it. So first of all, just go with pip install TPOT to install it on your system. And then TPOT depends upon scikit-learn and NumPy. So let's see how to work with it. So using our almighty famous Your Dataset, then later in the future we'll try and do something practical with it. So let's check it out. So I'm just going to import my ML packages and then my EDA packages, right? So we'll not be using these ones, you'll just be using the trinity split, and then be using these ones, right? So let's check it out. So I'll just come back here, let's create in some space to write some code. So let's load our dataset. So this is going to be loading our dataset. So today I changed my theme to white theme. Okay, so df then pd.read_csv, then I'll pass in my data URL, which is an iris data URL, right? So run is going to save it perfectly for us, and now we can do whatever we want to do with it. So the reason I'm using Colab is because I want to use TPOT, and then TPOT is faster, right? It's faster on Colab if you have a good GPU. So let's go with df.head to see our dataset, which is a normal iris dataset with our sepal length, petal length, and the rest, as we always do. And then I can now check for if there's a present or missing values. Because when you're working with TPOT, you should make sure that the data is numerical data, and then there are no missing values. So if I go with df.isNull.sum, let's check it out, making sure that there is no missing values there. And then if you check, there is no missing values right within them, so we can work with it. Now let's check for the columns that we have. Come back here, then df.columns, then we try and split them together. So we splitting them together, then we're trying to use TPOT to help us get the best algorithm, right? Instead of me using this long procedure of checking for using logistic regression, random forest, multinomial, different algorithms, with TPOT it's going to do it for you, right? It's going to pick the best from all of these algorithms for you, so you don't need to be doing them. So let's check it out. So I'm just going to split our dataset. Before we split it, let's first of all convert our species to numerical, right? So I'm going to map them. So it's going to be D for the dictionary. I'm going to create a dictionary that goes with value map to my index. Then it's going to be for my index and my value in my df species column. We are using a species column dot unique. Right, that is all that we need. So this simple stuff is going to help us generate a dictionary, and then we can use this dictionary to do whatever we want to do. So if I come back here, it's giving us an error because we missed something out. We must enumerate it, right? Let's enumerate it here. So enumerate and pass it around. Right. So this is going to help us create a simple dictionary, right? So we are enumerating it, and then we're going to give us a simple dictionary here. So if I go back and I check it here, I go with this option D. You can see that Setosa is 0, Versicolor is 3, and then Virginica is 2, right? So 1 is 0, 1, 2. So this is our mapping. Now I'm going to map that one out. So let's call it as my new label. Right, you can just use this straight away, but I just want to use this particular option. So df.species.map, then I'll map it with my dictionary that I've created. You can use get dummies to help you with this, but I'm using the simple one. Perfect. Now we have gotten our stuff, so let's check it out. So if I go with df.head again, now everything is as expected. So what I'll be doing is that I'll first of all use cross validation score to help us have an idea of how to use a single algorithm, right, to generate the best fit. So in that case, we'll be using an individual algorithm. So we're using logistic regression to help us with that. So let's call it as my, so I can just go straight away with this option. Let's call it as my CV, right? CV scores. Without splitting, we are using the CV scores to help us find the mean of the algorithm in case we use logistic regression. So it's going to be my cross. We have not imported cross, so we have to just import it from here. Let's go back to the top and import it. So we are using cross eval, right, to help us with that. So I'm going to import cross validation score to just have an idea of the mean in case we are using one algorithm, right? You are using logistic regression. What is the different folds we must use to get the best optimal result? So cross val score, and I'll pass in my value. So I must pass in my logistic regression. So let's go to logistic regression, right? That's the first one. The next one is going to be the particular label. So let's create our labels above. So this is the long procedure, but it will help us. So S, let's call that my S, right? S features. So S features is going to be my DF. I'm going to use from set power length to set power width. So I'm using all of these things. You can use the numbers if you want, but let's use this. This is simple. So copy this one here, and then I'll paste it here. Right, perfect. So that is something simple. Right, so this is going to be for our features, right? Then we also have our Y labels, which is going to be df, and then our new label, right? As we had here, this new label. So we'll be using the same thing inside our logistic regression, feed it inside logistic regression, and then it's going to be using several k-folds to give us the best optimal result, right? So to try and the same thing on this algorithm, then find us and give us the best option, right? So this is how it's going to go. So I'm just going to my S feature, right? S feature, and then my Y label. We are not splitting, we are just leaving it like that. My Y labels. Then from here, I'll just specify the particular score, right? So let's go with my CV score. So we can just give it, let's just say 5, right? Or 10. You can make it as any number that you want it to be. So let's make it 10 folds, right? So perfect. It's going to use the same thing, generate and give us the result, store it inside this variable. It's giving us an error, but it's still going to work. Perfect, right? And now let's check it out. So if I go back to my CV score, I check it out, it's going to give us a result perfectly despite the error. So it has checked it. So if I use logistic regression, this is the values that I'm going to get, right? All of these things, right? Some of them is going to be 100%, some of them are going to be 99. So I can try the same thing on a different algorithm. So I can copy this one here. Let's say try it on, let's say random forest or something. So let's try that one on random forest. So to find the best score, right, you can just find the mean of this entire stuff. So see what I'm doing. Okay, so I can find the mean of this by going, let's go with, let's say print mp.mean, using numpy.mean, then I'll pass in my CV score, right? So passing my CV scores, it's going to generate it for us and find the mean of this thing that you have. So the mean of them is 9.7, right? So 97% is going to be accurate. Perfect. So you can also try it on a different algorithm, then you change the parameters. So let's check it on random forest, right? And using the same thing, you can also try it out. So let's call that one as say rf, then try it on. You have to make sure that you change the parameters, add some parameterization to it. And if I go back and I check it as above, let's check this one to rf rather CV. It's going to give us a different result, right? So this is going to be the mean of them if it checks, right? This is 96, but this is 97, right? So what you do, that if I do the same thing, I modify the parameters for this one, for random forest, right? So let's modify this one here. So I can just give an estimator. So you see that we have an estimator here, we have estimator, we have criterion, we have minimum, split, and all of these things. If I modify these parameters, this is the default one, and I add it, it's going to give us a different result. So let's give n estimators of, let's say 100, right? and then let's give it a maximum depth of the tree or the forest. Maximum depth dpt, right? So you're giving it a maximum depth of, let's say, 2. So this is all the features you have given, right? There are a lot of features, but you have limited it to only these ones there, right? So with this same thing that we did, so this is going to be for 2. Let's run it and see what you're going to get. I'm going to run it, and then now we can also check it out. If I go back, let's give it more space. If I go back and I do this rf, so rf cv score 2, and I check it out, so the best among them is that it gives us let's say 0.93, 0.93, 0.86, unlike the other one which give us, look at this one. Let's bring it to the top so that at least in the future we can have it as a reference. This one give us this, right? For the first one without any parameters, it used the default parameters, give us 93, 93, 93, 93, 11. But the one that I modified the parameters, it give us 93, 93, and then 86, right? So that means that changing the parameters can affect the results and the accuracy of your score, right? So that is where TPOT helps you. So I cannot be doing this and changing. This is one of the simplest ways, right? But I cannot be doing this over and over again, right? If I check for the mean of this thing I've done, right, then I can actually find which of them is the best. So should I use logistic regression, or should I use random forest with these parameters? So this one is 95, right? This is 96, and this is 97. So should I use logistic regression? If I use logistic regression, it's going to give me 97. If I use random forest, it's going to give me 96 without any parameterization. And then here too, it's going to give me 95. So which one should I use? So this is why we use TPOT. So with TPOT, it's going to automatically run it and give us the result. So let's see how to work on TPOT using TPOT. So let's check it out. So we'll be starting from here. So this is going to be AutoML. So ML with TPOT, right? So first of all, in case you don't have, just go with pip install TPOT. I already have it, so but this is how to install it inside Colab. So I'm going to install it, then from here I can just import TPOT, and we see the various things we can do with TPOT, right? So it's installing perfectly for us, taking some time. That's finished installing, right? Now perfect, so that's finished. So I can import it, and we can see the various methods, the various attributes of TPOT, and what we can do with TPOT. So let's check it out. So with TPOT, it saves you a lot of time. So I can just check for the different methods of this. We have TPOT. It's going to be our methods and attributes. I check, right? So you have two main classes. We have TPOT Classifier in case you are working with a classification problem. You have TPOT Regressor in case you are working with a regressor. Then you have some other stuff you can also do, right? So let's check it out. So first of all, what we need is we're going to split our data set, train and test. So train and test as we always do. So it's going to be something simple. So I'm going to go with my S train and then my S test. Right, so you have to remember the order, then above, and then my Y labels. Right, that is all. Right, then I'm going to give my test size. So test size is going to be 0.3. That is 70/30. Then my random state, so that is all. Right, that's what we need. Perfect. So let's split it into 2. And after that, we are going to move on to the next option. Hopefully it doesn't give us any error. Perfect. Now let's create some more columns and cells. Okay, so the next thing that will be, after you have splitted our data set, you'll be using the same procedure we would have used in case we were using maybe logistic regression or any other model. So we are going to initialize and store it as our variable. So we're initializing TPOT, so it's going to be TPOT. Then I'll go with my TPOT classifier. Remember that we had classifier here, right? TPOT classifier here. So that's what you're trying to use. So TPOT classifier. Then I'm going to give it some parameters. So the parameters here is going to be these ones listed above. So I can specify the generations, which is the number of iterations I want to go. How many generations do I want to iterate over, right? So generations is going to be 5, right? the default is 100, but because we are doing this tutorial, we want to make it short, right? Just 5 generation. The more generations, the longer it's going to take. Then you can also specify the population size, and then you can also specify some of these parameters. But let's make it simple with this. So I'll give it my verbosity, so that at least I see what is happening. So verbosity is equal to, let's make it to 2. Perfect. That is all that we need, right? So this simple stuff is going to initialize it. Now the next thing is to fit our data to it. So just come back here, then I'm going to fit my data to build relationship among our data set. It's going to be my tpot.fit. Now passing my s train and then my y train. It's going to build some relation between them and then give us the best optimal stuff. So in this place, it's going to use these generations and then keep on building iterations there for us. So this is where it takes time, right? It's going to run this particular stuff. So that's why I'm using Colab to help me with us. So you can see from here that it's optimizing process, as you can see here, 7%. Then it's going to give us the particular generation. So it's going to build the first one, find all the best possible combinations, then give us the right result. So I'll pause it even as it's taking time, then we move on. So we'll be picking something from here whilst it's running. I'll pick some values from what we had here, right? So this is Setosa, right? I can pick one of these values, then we use it to predict, right, what kind of species is going to be in the next session. So it's going to take some time for it to run. This depends upon how fast your system is. Perfect. So now it's going to run. It took some time, right? So now just finish. Then after it has finished, it's going to give us, these are the results, right? The CV score, just as we did above. It's going to give us the best one. This is just for only 5 generations, and this is the one it found. So it found out that KNN classifier is the best, right, algorithm that we have to use for this particular issue. Very interesting. But the more I increase it, the more it's going to find more optimal algorithm, right? Because I use just 5 generations. So let's see how to get these results. So now I'll just come back to the same place. I can check for the score of it with our testing data. So it's going to be tpot.score, and I'll pass in my values to s test and then my y test, as we always do, to get the accuracy, right? So that is another way you can also do. So this is going to give us the accuracy score of what we have above. Just as we did, it's going to give us 1. That means that it's very, very optimal, right? It was able to give us the optimal result of 100%. Very interesting. So how do I get these parameters, right? So I can actually export it. I can export those. I can export TPOT to get the result. So export the result. In that case, it's going to be something like this. So tpot.export. Then from here, I'm going to give it a particular name that I want to give, right? So this is the name you'll be storing it inside. So let's call this, let's say, TPOT, right? This ML pipeline, something like that. Py. So I'm literally going to save it, export the result into this particular result. So I can just come back to this place, my sidebar, no, my menu here. In case you are working on a system, it's going to save it in your direct location, but inside here, it's going to save it here. So TPOT ML pipeline, right? Then I can actually save this one. So let's download it, and then we can see the result there. Very interesting. So with this thing that we have done here, so let's save it and you open it later. So with this thing that we have done here, right, we can actually make some predictions with this stuff, and it's still going to work. It's going to be using this same algorithm, that is the KNN classifier, to help us with that. So I can also make some simple predictions. So let's call this predictions. So let's give it some value. So let's go to example. This example is going to be using NumPy to create some values. So NumPy.array. We are picking any values, right? And we're going to be checking it. So let's go with 6.2 and then 3.4. Then let's reshape it here. So this is supposed to be corrected to 5.4. So let's run it. So I run this particular stuff here. I'm going to reshape it perfectly for us, and now I can check it out. So let's make our prediction. So tpot.predict. Then I'll pass in my example. It's going to give us the right prediction, right? Perfect, which is 2. So in case I want to check what 2 is, if I go with my dictionary of which we did above, 2 is going to be, let's say, Virginica, right? Very interesting. So it's able to give us the right prediction, right? So you can even use this one to help you with that, and you can even export this stuff, but it has automatically exported it in this particular file, and then I can open this file, right, and then actually see the code and the right parameters to use. So let's check it out. Come back here, and if I open it back, you can see that this is the result. So in case I want to do it again, I just going to use the same thing. So it's going to give us all of these things by default. Then what you need to do is that you can just place in your data here, right? Then you just go straight away and make sure that you rename it to target. Your target is going to be renamed to target. That is all, right? And then you can use the same thing for us. That is one of the ways. In case you don't want this long step, you can just pick this stuff here, this thing here, and then try it on it. Perfect. So that is how to work with TPOT. It's very, very powerful. Automatically going to generate everything for you, then can use it to do whatever you want to do. So you can use this entire stuff here, or you can just copy this one and then use it, right, as you wish, right? Very interesting. So thank you for watching this long tutorial. So the basic idea is that you just have to prepare your data. After preparing your data, you just initialize it here, right? Then you specify the particular generation that you want, maybe 510, as much as you want. Then you're going to fit your data set together. It's going to take some time and find the best algorithm as well as their parameters. Then you can check for the score. You can also export it and then see your result and use it to do whatever you want to do. So thank you for watching this tutorial. In case you have any question or contribution, you can just put inside the comment section below, and please don't forget to subscribe. Thank you for watching, and see you in the next session. Stay blessed. Bye.